Welcome back to the channel. So I was recently at the American Chemical Society, and I gave a talk on my upskilling journey from grad school to being a professional analytical chemist, measure scientist, and now as a data scientist. And I had a lot of people who really enjoyed the message, and they enjoy data science. They have this domain knowledge, but they don't necessarily have the time to learn how to code, or they're still pretty early in their journey, despite knowing many of the tools that come along with data science. I want to start making a few videos that are sort of targeted at this group where you're an expert in the data, but perhaps you lack the programming skills, but you want to kind of dabble. You want more than Excel, but not quite writing your own code. And so as part of this, there's some software called Orange that I think might be just the fit. So here is the Orange webpage, it's orangedatamining.com. This comes along usually with the Anaconda installer, and you can see you just go to this download Orange link and then find your flavor. Orange is basically like a canvas, and with that, you can drag and drop nodes to do the data processing from importing data, cleaning data, visualizing that data, and even building models if necessary. So let me show you a little bit what you can do. And if you enjoy this, I can make more videos demonstrating this in more detail. So here we have the canvas. And on the left side of this window, we have several tabs. So one for data, where we can import our data, several transforms, group by, aggregating columns, things that you will often see in the data processing workflow, several ways to visualize data from heat maps, bar plots, violin plots, and many more, as well as several models right at your fingertip, logistic regression, naive Bayes, and several of the oftentimes award-winning models, as well as ways to evaluate those models through ROC analysis, confusion matrices, and unsupervised learning. So such as manifold learning, as we've demonstrated in one of the previous videos, and one of my favorite, PCA. So let me just show you really quickly what we can do here. So if you start with one of the data sets that we can generate from online, we just go to this data sets, and this will load a data set from the online repository. You click that once, and you can double click this node, and we have several data sets at our fingertips. Iris is one of the most common and the one I made my first video from. So let's use that one. So to use it, you just click it, and we can close this window and go back here. And let's visualize this data set. So we go to the Visualize tab, and let's make a scatter plot of this data set here. And from here, we now have another window that is plotting the data. So it has read the data. We can plot the petal length, sepal width, and petal width. And we can also color these points based on any of these quantitative variables or this categorical variable here, the iris species. And so here, this is really useful. This has a way of finding informative projections, which will basically optimize the separation between this color attribute, which is more useful when you do things like PCA to help sort of determine which components might help you visualize the separation between some category of interest. So let's do that. So to run PCA, we just drag our PCA node on here. We can bring our data set down to this, double click the PCA, and just like that, it's run. One of the options is to normalize the variables, and so we are doing that, and we have 4 components because that is the maximum number we can have. Although, as you can see, by the time we get to our 3rd component, there isn't much information gained, and there's only 4 variables, so it's not really an ideal practice to have as many components as variables. So just out of principle, let's not do 4. So let's close this window, go back to our main canvas, and now we have our PCA model. To understand what it has done, let's now go to visualize that data and run this, make another scatter plot, double click that, and now we have a way to look at this data in many different ways. So let's go to PC1 versus PC2. And you can see that, again, as we've seen many times when we've programmed our own data, that the iris setosa separates pretty clearly from the other 2 species. As well, we can manipulate the symbol size, the opacity, the jitter allows some of the points to no longer be overlapped and sort of allows for better visualization, as well as many other ways to handle this data. And so this is a toy data set. Let's look at some other data that we've looked at in previous videos. To do that, you could just select the CSV file import. And in your case, you might go to one of your data sets that you're familiar with. I can go to my recent files or select this folder and drag this like you would an Excel file. Or I can go to this folder and find the file on my computer. And just like this, we could do the same thing. So Let me actually drag a new node to PCA, and we're going to run PCA on this soil fertility data. So if you click here, you can see a preview of the data. Unfortunately, it's loading on my Mac screen, not the screen I'm recording. But we've talked about this data many times in many videos, so I'll bypass it for now for the sake of this demonstration. And so let's now go back to our scatter plot. It's automatically updated. And if we plot PC1 versus PC2, and let's say in this data set, we have two fields that we're sampling multiple data sets from, we can see that we have a clear separation between field 1 and field 2 and blue and red respectively. And again, we can manipulate the way this figure looks, and we have a really easy way to handle sizable data sets and do some of these models that we have demonstrated. As well, you can see that many of the other variables already exist as well. So not that you'd want to be in the practice of plotting some of the original variables with the new variables, but it's an option, so use it at your risk. I mentioned earlier this ability to use the fine informative projections. And so this is particularly useful when you're doing PCA, because you can use this to figure out which components might help explain or at least visualize the separation, in this case, of the field. And so if we look at PC1 versus PC3, the length of this bar tells you how well it separates, but be careful because some of these would make sense, such as the ID, because in this case, all of the early samples were measured first. So they're like 0 through 50 is class 1, and 51 and to 100 is class 2. So be careful with that. In any case, you can choose the principal components and see that if we look at PC1 versus 3, we do have really good separation. If we look at 1 versus 2, a little bit more clutter, but still pretty well separated. If you go down to the bottom, you can see how this line gets much smaller. And so just let me show what it does look like for some of the others. And those classes are pretty much completely overlapped when you look at this. And so just a really cool way to develop some insights without writing code. And as you can already tell, there's many more things we can do with this. This is just a very simple overview. And so I challenge you to give this a shot. And I'll make more videos like this if you find this useful. In any case, like, comment, subscribe, and I'll see you in the next one. Peace.